Okay, assignment for question 3. Question 3, you are required to construct an energy cycle and then to calculate enthalpy change for this reaction. So this is our aim equation. So we've typically given so many different enthalpy change. I've advised you guys as a start to write out the accompanying equations for this enthalpy change, so that you can see how these equations can be linked to the aim equation. So formation of water, definition of formation, it's 1 mole of the substance formed from its elements. So 1 mole of water formed from hydrogen gas and oxygen gas. Okay, formation of H2SO4, same thing, 1 mole of H2SO4 liquid formed from H2, hydrogen gas, sulfur, and your oxygen gas. Okay, so you balance the equation accordingly. Enthalpy change of formation again. So all these 3 are formation, formation, formation. So 1 mole of sulfur trioxide from sulfur and oxygen gas. Last but not least is combustion. Combustion, the definition is slightly different. It's 1 mole of your compound substance being completely burned in excess oxygen. So in this case, it's completely burned to form SO3 gas. Okay, so it's necessary that you do this as a preemptive step first, right? So that you guys know how to link this up. So now to the construction of the energy cycle, this is our aim equation. So write this down. So typically, as I mentioned many times, all arrows need to be accompanied with delta H or at least a value. So this is unknown. We call this our delta H reaction. One look at this equation, you realize that, okay, you have H2SO4 over here. There's only one equation of H2SO4, which is the formation of H2SO4. So over here, this equation, H2 plus sulfur plus 2O2 to form 1 mole of H2SO4. But over here, you have 2 moles of H2SO4. So as a result, naturally, I will times 2 to this entire equation. So I call this 2 times delta HF of H2SO4. I'll need 2 sulfur, 4 oxygen gas, and then 2 times 1 of hydrogen gas. So it's 2 sulfur, 2 times 2 of oxygen, 4 oxygen gas, and 2 hydrogen gas. And this is 2 times delta HF of sulfuric acid. Okay, equivalent to, I can just write 2 negative 811. Once this is done, then I try to link this part of the energy cycle to the left hand side, because the right hand side species have already been linked. So in this case, I have water, 2 moles of water, and I'll need 2 moles of H2, and then I split this up into 1 mole of O2 gas. And now on this side, I have 3 moles of O2 gas. So this 1 mole of O2 and 2 H2 gas will form 2 times delta H formation of water. And then the remaining 2 sulfur and 3 oxygen gas, if you take a look at the equation, alright, you have to form SO3. Why can't I form SO2 directly? Because in this entire equation, you do not see any reaction that forms sulfur dioxide from the elements. Alright, there's no formation of SO2. So I form SO3 first, and because 2 moles of SO3 are being formed, I need to times 2 to this entire equation, and therefore it's 2 times delta HF of SO3. And now you see the only missing is from sulfur dioxide to sulfur trioxide, and therefore this will be your combustion equation. Sorry, my apologies. The earlier equation for 2 moles of SO3 from this is this equation here. Alright, formation of sulfur trioxide. Okay, and then the SO2 to SO3 is your combustion. Alright, because 2 moles are being combusted, you need times 2 to this equation as well. So you have 2 times delta HC of SO2. So with that, everything is balanced. Alright, you atoms 2 sulfur plus 3 oxygen gas to form sulfur trioxide, 2 hydrogen gas plus 1 oxygen gas to form water, and then 2 SO2 plus this O2 to form your SO3. So all in terms of atoms, everything is a balance. Now it's just applying a Hess law. The red arrows are actually your clockwise arrows. Alright, the green arrows are your counterclockwise arrows. So apply Hess law. So the red arrows equals to the green arrows. Sub in your values. Okay, so you have formation of sulfur trioxide, 2 times negative 493, 2 times delta HF of water, negative 2 times negative 286, delta H reaction, delta HF of H2SO4, 2 times negative 811, and then combustion of SO2, which is 2 times negative of 98.5. Okay, so as a recommendation, you can consider putting in the values here. 2 times of negative 286, 2 times of negative 493, and this is 2 times of negative 98.5. Okay, so that can help you sub in a value easier. And should end up a value of negative 261 kg per mole. Okay, part B is a pretty short, simple question. We're looking at feasibility of the reaction. So feasibility of the reaction, we look at delta G. And since delta G, we know that there's two terms affecting delta G, delta H and negative T delta S. So part 1 term, part 2 term. So in this case, delta H is given, is exothermic. Delta S, we can also infer from the reaction. This delta S is going to be negative. Why? Because you have 3 moles of gas to 0 moles of gas. So it's going to be exothermic. It's going to be decrease in entropy because there's a decrease in number of moles of gaseous particle, and therefore negative T delta S is therefore positive. Okay, so delta S negative, negative multiplied by a negative number, alright, you get a positive value. So given that delta G equals delta H minus T delta S, in this case we need to consider high temperature and low temperature. Low temperature, negative T delta S, this term, alright, it's going to be smaller than the delta H term. So recall what we mentioned in tutorial, we compare the magnitude. So if delta H is bigger, in terms of magnitude, delta H being negative, it will outweigh the positive term, delta G will be less than 0, and therefore this reaction will be feasible. At high temperature, your negative T delta S term will be outweigh your delta H term, delta G will be positive, and therefore not feasible. And therefore this reaction is feasible at low temperature, but not feasible at high temperature. Okay, so with that, this is our standard phrasing for feasibility, qualitative explanation. Okay, you need to consider both low and high temperature, especially so if the two signs here differ. Alright, delta H negative. Alright, but negative T delta S is positive. Alright, so especially if the two signs are opposite of each other, we need to consider the different situations at both low and high temperature. So with this, there are 2 ticks per mark. Every 2 ticks you get 1 mark. Okay, and that's question 3.